Hello and welcome to another exciting video here in Mathland. Today we're talking about binomial expansions and finding the blank term. So we're looking for the whatever term in this expanded binomial without actually expanding it out. Okay, so in this example we have a minus b all raised to the 17th power. We're looking for the 8th term. Now we can use our calculator to help us out, but we have to understand how we get there. Okay, so in expanding binomials, we can use the NCR method in our calculator. The n is the degree that the binomial is raised to, so it's going to be 17. The c is the computation that the calculator does for us and finding the combination there. And the r relates to the degree of the second term in the binomial set. So this guy right here. Okay, so what degree that's raised to is going to determine that r. Okay, so if you watched the video or you were paying attention in class on the binomial expansion, when we expand this entire binomial sequence, the second term doesn't show up until the second term listed out. So if we were to write this out, it would be a to the 17th and no b term. Our next term would involve the a to the 16th and b to the first power. So since it doesn't occur in the first term, we have to go one down from the term that we're looking for, because this relates to the second term and this relates to the actual terms in the lineup. So this is going to relate to the first term. It's going to be the 8th spot that the a shows up, but it's only going to be the 7th spot that the b shows up because the b is not in the first term. Okay, so if you're confused about that, you can go watch the video called Expanding Binomials, and you'll see how the first term and the second term are related as far as increasing and decreasing with their degrees. Okay, having said all that, the short version is subtract 1 from here, and that's going to go to your r. Okay, so that's going to be c to the 7th. So minus 1, that's going to be c to the 7th. Okay, so that's going to be for our coefficient in this expansion here. Okay, so I'm going to put this in my calculator. It is going to be 17 math probability combination to the 7th. There we go. Wow, so that's a pretty big number there. Okay, so we've got 1, 9, 4, 4, 8. And we know b is going to be to the 7th power, so I'm going to skip a space, put b to the 7th power, and I know that the a has to be 17 minus 7 because these have to add up to this overall degree. So it's going to be a to the 10th power. 10 plus 7 is 17. Okay, another thing we have to think about is this negative sign right here. That's going to play into this coefficient to tell whether it's positive or negative. Now, the thing to look for is this exponent right there. We know that we subtracted 1 from the term we're looking for to get 7. Okay, and that's going to be b to the 7th. Now, if we have a negative in front of that second term, we know that a negative number to raised to an odd power will keep it negative. For example, if we had negative 1 to the first power, that's going to be negative 1. But negative 1 to the second power, that's going to be a positive. So if we know that that degree of the second term here is going to be an odd number, it's going to carry that negative sign with it. So our answer is going to be negative 19,448, a to the 10th power, b to the 7th power. I hope this makes sense. We can do another one that's a little bit more complicated. Just a moment. And here we are. We have another example. It's like magic. Okay, so a little bit more complicated, but I think you can do it. Just hang with me. Okay, so we're going to do the combination help here with the calculator, but first we have to figure out what this is going to be to. So let's lay out our combination here. So overall, we're to the 8th power. So 8C, I'm laying out my NCR here. And the 6th term, remember we subtract 1, so it's going to be to the 5th power. So 8C5. Okay, so we're going to put that in the calculator. Am I still in here? Yeah, okay. 8 math probability. Ta-da. Let's see, 5. Okay, 56, not bad. So that's going to be our coefficient for this setup here. Okay, so I can't remember that. That's our Pascal coefficient. We have to consult him first before we do anything else. Next, we have to figure out what these look like. So I know that this second term right here is going to be to the 5th power. So it's going to be 56. I'm going to skip a space for this guy. He's going to go there. And then my second term, negative 2y to the 3rd power, is going to be raised to the 5th power now, because remember, that came from that second term. What that second term is going to be raised to. Okay, so we're going to take that second term and raise all of that to the 5th power. Okay, we're also going to figure out what this first term is going to be raised to as well. So I know if the second term, all of that is the second term, don't let all these exponents and coefficients mess you up. But this is just the second term. I'm just bringing down whatever's here, and I'm raising it to the 5th power. Now before we just had a b, and that was fine. We just put a b down there. It's the same thing. It's just whatever's there, I'm putting it down. So this second term is raised to the 5th power. Now I know the first term has to be raised to something that we have to add to 5 to get to 8. So 5 plus 3 is 8. So first term to the 3rd power, second term to the 5th power, that equals 8. We've got it right there. Okay, so now let's go ahead and multiply these together. Okay, so we're going to have 56 times 3 to the 3rd power times negative 2 to the 5th power. Okay, so just look at the coefficients. 56 times 3 to the 3rd times negative 2 to the 5th. Okay, and we get, wow, negative 48384 is my coefficient. Now I need to put in my variables. So when we have a power to a power, we multiply. So that's x to the 6th. And then 3 to the 5th, we're going to multiply those. So y to the 15th. Okay, so we took everything down from it. Don't let the big numbers and the other exponents trick you. You're just putting them down here as the first term and second term. And that is all we do there. That's it. Enjoy.